Requirements engineering. So the requirements engineering process is sort of like waterfall in its in a mini waterfall for just the requirements engineering part of the process. So you do first elicitation, where you find the requirements. The analogy is that you're walking around with a flashlight and the requirements are there for you to find. So you light them up, you elicit them with the flashlight, and oh, there's a requirement, and you take note of that. Once you have your requirements, you analyze them, make sure that they are complete, consistent, correct, viable, etc., etc. And if there are things that you need to negotiate with customer, like, yeah, we can't do all of this, or these two requirements are in conflict, or something like that, you do negotiation. Once you have done this, it's time for doing documentation, which is, well, you've done documentation during the elicitation, you've done documentation during the analysis and negotiation as well, but this is where you finalize it into one requirements document. This requirements document is then validated to make sure that you have all the requirements you need, you don't have any more conflicts, you have a viable plan forward from your requirements, that it's implementable and it's consistent and all sorts of things. The main outcome from this process is, well, first of all, that you actually talk to the stakeholders. The people, a stakeholder is someone who has some interest in the process. This might be end users, this might be your customer, it might be a legal body who has some requirements on your product. Let's say you're doing a payment service, then perhaps legal bodies, banks are also stakeholders. It might be your boss who has an interest that you actually develop this product within a certain time frame because you're required for other products or something like that. So all of these people are together stakeholders, and part of the benefits of doing requirements engineering is that you get to identify who are all the stakeholders that you should talk to, and then you actually talk to them. You get their input to the process. And the other outcome is, of course, that you have a requirements document that consists of the requirements that you are supposed to implement. The requirements document, or software requirements specification, SRS for short, is used in many places. This is just a small selection of the places where you would actually use it. You would use it as a contract with the customers to agree this is what we are developing. Uh, this is not a contract per se, but in the contract you would reference the software requirement specification and the particular version of the specification. You use it to communicate with the customers and stakeholders. You can show the requirements, you can talk about them on different levels, and you can talk about, do we have all the requirements, is there anything missing? And when you need more information, you know how to have a targeted discussion in order to find that information. You can use it as a bridge between the customers and the developers, so the developers don't really, according to some philosophers at least, the developers don't really have to talk to the customer, but they can read the requirement specification and then see what the customer needs or wants. One very important use for the requirements document is also that you use it as a blueprint for testing. So once you have the requirements document, you can start planning your testing effort. You don't do testing based on what you implemented, you do it based on the requirements that you had. The document itself, you can write this in many ways, but there is an IEEE standard, A30, that basically gives a rough outline. These section headings should be there. There should be an introduction, there should be a general description section, there should be specific requirements section, there should be appendices and an index. Within the introduction, you discuss the purpose of the document, the scope of the product, so what should be in the product, what shouldn't be in the product, what should be definitely not in the product. Definitions, acronyms, things that are needed to actually understand what the requirements specification talks about, any references to external documents, and then an overview so that a new reader can find their way through the rest of the document. The general description section is an overview of the product you're building. Usually there would be a picture showing where users are, if there's servers involved, and how data is passed back and forth, and things like that. User characteristics is also here, where you describe the different uses of the system, so that you have an idea when you read the rest of the document. You know when you're referring to, for example, a customer. In this requirements document, a customer is a particular type of user that has certain characteristic. The specific requirements that's basically where you list your requirements. You have your functional requirements, you have your non-functional requirements, and you have your interface requirements. And appendices and indexes, well, list of terms. Appendixes is, well, if you have anything that is supplementary information that you need in order to understand what the rest of the document is all about. The individual requirements, they can be written in many ways. One good starting point is to have the basic terminology in place, so when you use the words must, for example, that has a specific meaning. There is an RFC, request for comment 2119, that goes through different ways, different words that you should have, or actually shall have, in your requirements. A common mistake, at least in Swedish, is to mistake shall from and should. So a lot of Swedish people would write should as a requirement, so the user should be able to log in. No, the user shall be able to log in. And once we have that in place, we can start talking about some simple template for the actual requirements itself. So I've got 4 examples listed here. First one is the product shall be able to record that a room is occupied or for repair in a specific period. So these are requirements for a hotel management system. Second requirement, the product shall be able to show and print a suggestion for staffing during the next 2 weeks based on historical room occupation. The supplier shall specify the calculation details. As you see, all of these requirements are using the shall form, so it's imperative. These are actual requirements. There's no wiggle room. You must implement them. And they all follow roughly the same template. So you have a unique ID, R1, R2, R3, R4. You have an actor. In this case, it's all only the product. The product shall be able, the product. And then you have the shall be able to, and then something, an action. Record that the room is occupied, show and print a suggestion, specify the calculation details, run in a mode where rooms are not booked by room number. If you have any specific constraints that this must be done within so and so many milliseconds, or unless the following, or so I shall be able to book a room unless the hotel is closed for maintenance, or unless there's an earthquake going on, or whatever, you would list them at the end. This takes you a long way. A simple requirements template, and you know that if you use this for all the requirements, you know that, well, you have the most vital information there, at least. If you want to be more elaborate, you can start using different attributes. So the first one is more or less the same. You have a requirements ID. You have a description. Same idea. Actor shall be able to action by initiating event. Or you can use the same template that we had on the previous page. You have a rationale where you actually explain why is this requirement important. Why is it important for an actor to be able to do this? And if this isn't enough, you have a source. Who mentioned this requirement? When did they mention this requirement? So if you don't understand the rationale, if you don't understand the requirement, or if you think you need more information, need more information about the constraints, for example, you need more information about the initiating event. Is this the only way I can do this, for example? You know whom to talk to. Where did we get this requirement? Fit criterion. Now we're talking almost test cases already. So if we implement this requirement and if we test it, what do we need? So what would be a passing test case? The next two, customer satisfaction and customer dissatisfaction, gives us an input so that we can prioritize this requirement. Customer satisfaction is that how happy is the customer if they get this requirement. Can be on a scale from 1 to 5 if you want to make it simple. 5 meaning, yeah, I would be really happy if I get this requirement, and 1 is meh, I can do without it. If I have to sacrifice one requirement, this is okay to sacrifice. Dissatisfaction, spelt like an idiot here, but anyway, dissatisfaction is how happy is the customer if they don't get it. So if I say, for example, the panic button in a nuclear power plant, yeah, the customer might not be very happy if they get it. On the other hand, if it's not there, they're going to be really sad. Dependencies, are there any other requirements that are related to this one? Conflicts, if there are other requirements that are in direct conflict with this one, so that I cannot implement both this requirement and those other requirements, with an explanation to why, you would link those here. Support material, any documents that can help you understand the requirement, if there's a legal text to include as well, or some user manual or whatever. And then you have history. Who wrote the requirement? When did they introduce? When they write it? When did they write it? Who has modified the requirement? When? Why? What has happened to this requirement? So you can follow it. You can trace it through history. This is important so that you know, well, whom to blame if we talk in modern configuration management terms. So if there's anything wrong with this requirement, if you don't know how to implement it and you can't get hold of the source, well, you can look through the history and see whom else has been touching this requirement and why have they done it? Why have they touched this requirement? Scrum requirements, if we go back to the agile side of things again, they don't use a requirements document as such. Instead, they would talk about the database of requirements, the backlog, their prioritized list of requirements. And then from this backlog, they would agree for each sprint which of these requirements they should work on. These requirements would be expressed as user stories, and again, I stress that user stories aren't use cases. And the idea is to have just enough information so that you can communicate with the customer and the developers. If you need more information, well, the customer should be there so you can ask them. And once you've got the sprint up and running, well, you shouldn't have that need for more information. And the idea is that rather than having this long and elaborate way of dealing with or specifying requirements so that you can basically hide yourself in a basement for 2 years and develop, you have your customer easily available so you can get the priorities properly. You should get them before you start the sprint. You have the reason why readily available as well. Some would advocate a template for Scrum requirements or Agile requirements. And so they would say, as a type of user, I want some goal, so that some reason. This includes a lot of the information that we had before. There is a slight difference here. The previous requirements or standard requirements that you would see in the requirements textbook focus on that the product shall be able to. Here we say, as a user, I want to. I hope you notice the difference in philosophy there. We also include the rationale already in the requirement. There's some reason thing here. So as a customer, I want to borrow some books so that I can learn new things. As a user, I can back up my entire hard drive so that I don't lose any data. And so on. So this is a slightly different type of template, a slightly different focus on it, focusing more on the user and what they want rather than what the product shall be able to do. Of course, the product then needs to support this in some way. but it doesn't state exactly that it is the product's job to do this. It might be the product together with, for example, a librarian. Scrum requirements, they are usually often written on something made to look at least like post-it notes. So you have the requirement on one side, as a user I would like to blah blah blah. And on the flip side of this card, this story card, you would write the acceptance test, conditions of satisfaction. These are basically your, so when you've implemented it, this user story, you can turn the card over and you can see, do I fulfill these criteria that are listed at the back of this card to make sure that I actually have implemented it to the satisfaction of the customer. So here's an example. I've obviously you can't see the back of my screen, so I put both the front and the back of this card in the same card, but I think you get the idea. So we have a story, select holiday season. As a vice president of marketing, I want to select a holiday season to be used when reviewing the performance of past advertising campaigns so that I can identify profitable ones. Conditions of satisfaction, this is the backside then. And then we have a list of things that we need to make sure that these hold true. And if they don't, well, the customer or the vice president of marketing won't be happy enough with us. It should work with major retail holidays. We should span 2 calendar years. We don't have to worry about the third year because it's 2 years moving window. We can set holiday seasons from one holiday to the next. In the US, for example, we can start at Thanksgiving and end by Christmas. And we can have holiday seasons to start a couple of days prior to the holiday, if we want to. Now, coming to the unified process way, or rational unified process. Requirements here are the starting point of analysis. And yes, you would list embryos to requirements. You wouldn't go through all this trouble that we've gone through for regular requirements. And then you would go on and write them as use cases and use case diagrams. These can, in the same way, be used for communication with stakeholders and developers. We can use them for testing. And in the next video section, I'm going to talk more about use cases and how they look. So don't worry about that. We use them as input for domain analysis because the domain is described in them. The objects, the actors, concepts, attributes, and associations should all be there, sort of. So we can use this as a starting point for our future analysis. We can do the same thing with regular requirements, but the idea is that we use cases. We put these requirements into a context, like small scenarios, where we see how the different requirements fit together. So the domain analysis is based on the use cases, and then we build upon the domain analysis in our detailed design then, and we take our conceptual model and make it into a class diagram and interaction diagrams and all sorts of fancy things. And the idea is also, since the unified process is iterative, that we start with something that is a simplified version of a use case. We don't have to go through all the details. We make a fairly terse short form of the use case, and we implement a simplified version of that. For the next version, or next iteration, we implement perhaps a full version of this use case, and then we build up with more and more use cases. Of course, we will not focus on just one use case per iteration, but same idea, that we start with a simple use case. Let's say if there's one straight path through a use case, through a scenario, this is, if everything goes right, we can do it like this. That's perhaps what we do in the first iteration. For the second iteration, well, if anything goes wrong somewhere in this process, what happens then? We might put that into the second iteration. All right, thank you.